Hi, good afternoon. It's Jim from the mavestar Observatory. A little bit later on in the video, we're going to look at the new sensor that we'll be adding to the observatory. It's the oxygen sensor. It detects how much oxygen is in the atmosphere. So, like I say, I'll show you that a bit later on. We'll talk about that. And also, I just wanted to share some ideas and thoughts with you with regards to what we're looking at, and just ask a few questions. What your thoughts are? How long do you think we would last if we were subject to what happened to the Vikings? Because I think it's important, because if we look at what's happening around a lot of the northern hemisphere right now, it does seem to be cooling, and as a result of that, we're seeing land and agro go offline. So before we get into that, as usual, guys, want to thank those few people that have stepped forward and took it upon themselves to start supporting us. That's amazing. And we've had a few extra people on Patreon as well as PayPal come forward and support us. So it's amazing, that is. So big thanks to all you guys that are participating in that. So if we go back 1200 years on this chart, we can see that the Vikings arrived in Greenland, and the reason probably why they settled there is because obviously the temperatures were marginally above 0 degrees, and that is a big difference. When temperatures start to drop below 0 degrees, things start to freeze up, as you commonly wouldn't expect and know. But that is really the difference between being able to raise cattle and grow crops. And you can see that for a period of time of around about 50 years after they settled, say about 100 to 200 years, or about 200 years, you can see there's a dip where the temperature goes below 0 for around 50 years, and then peaks back up for another 100 or so years, and then dives back down. And by that time, the Vikings have had enough. They've probably been informed by their ancestors, of a time period where they had to survive in those temperatures and how hard it was, and carrying that knowledge of their ancestors, decided to give up. That I've got to ask the question to you guys. Do you think 800 years ago, when that climate dipped below 0 degrees for around 50 years, do you think if that happened in this modern day and age, that we would probably bear it out for the 50 years? The thing is with the Vikings is they weren't very technologically advanced. They had ships, so they was more than capable of navigating the oceans. So it wouldn't have been a problem for them to, if they couldn't grow crops and their cattle couldn't survive in sub-zero temperatures, at least they could take to the oceans and collect food from there. But how long do you think we would survive in this technological advanced society? Do you think we would last 50 years in sub-zero temperatures? Because I'm pretty sure the grid would go down probably within a couple of years, so we wouldn't be having electricity run to our homes after a few years of just experiencing constant sub-zero temperatures like the Vikings did. And of course, when our electricity goes off, the grid goes down, fuel, logistics, everything starts to clog up and break down. And we've seen the scenarios when the grid goes down, and this is just related to when temperatures dip below 0 degrees. Let's have a look on Google and just see how far Greenland is compared to, and we'll also compare where the last glacial period is, because I think it's important to put this on the table, because according to historical records, we are supposed to be entering now another glacial period, and perhaps what we're seeing slowly take place over the northern hemisphere is a merge back into a glacial period. And I've got to ask the question, how close is it, and how far are we away possibly from that actually being the case? Let's have a look at Google Earth and just see how far, and compare where the last glacial period ended and how far it came down towards the equator. So during the last glacial period that we experienced, anything around about 52 degrees north was covered in snow and ice, and glaciers that were moving from the Arctic region. And we know this because I live just in central England, and there's a lot of glacial till that's been deposited around 52 degrees. So we know that where the till is, which would have been the debris that the glaciers would have pushed further north from Scotland all the way down, we know where these stones originated from, and we know that the only way that they could have ended up in pretty much a straight line across central England or around 52 degrees is by melting glaciers, and they would have left all that debris that they dragged, you know, further north down at the point where they melted. So we know that from around 52 degrees north, anything above that was probably covered in glaciers and snow and ice. And if that happened today, most of Canada would be covered in snow and ice, and most of Europe, Siberia, would be also covered in snow and ice, and you know, pretty much the northern parts of Siberia most of the year round is covered with that. But these are the least occupied regions on our planet. You know, the further north you go, and as you can see, Greenland, we've got a measuring tool from around central Greenland to 50 degrees, and we can see that that is equivalent to about 1,396 miles, which isn't a lot really when you think about it. And you know, it almost puts it into perspective on how close we could possibly go back into an ice age. I mean, we do have winters in the UK where we have regular snowfall. Sometimes it's worse than others, that's just weather. But you know, it's like everything, guys. At the moment we are seeing droughts in some parts of this world, floods in some parts of this world, and we're also seeing sub-zero temperatures now creep in on some parts of this world. And although a lot of people will say, oh, this is just seasonal weather, but the point is this, is that they seem to be frequently occurring. You know, if it's catching farmers out in Canada and say North America right now, then you know, you've got to ask the question, are we seeing a shift you know, in the trend that we're seeing? Is it actual a return into the glacial period? And you know, it's going to be hard for us to answer that, because the last time we came out of the glacial period was around about 12,000 years ago. So it's not really that long in the Earth's history back that we was in a glacial period. And you know, we have been through many glacial periods throughout the millions of years of history. So you know, these things do happen. But you know, if you think about how many people occupy this world above 52 degrees, it's in the billions. And you know, there's a big problem, as you can see, with, you know, as you go towards the Tropic of Cancer. You know, there's a lot of desert on our planet. It's a lot of land that isn't capable of growing a lot. Even though if you study recent satellite photos, that, you know, we've been enjoying CO2, and the satellite photos actually show that this Earth is getting greener as a result of that. So obviously, plant life and vegetation is thriving from the rising CO2 in the atmosphere. You know, I'm not going to go there, guys, with, you know, global warming and CO2, because, you know, since 2007 we see a slow decline in global temperatures, and you know, the CO2 is still rising, and that's all that needs to be said about that. CO2 is not causing global warming, and from what we was discussing over the last few days, the grand solar minimum doesn't directly cause global warming, but we do know that it can significantly affect, as a by result, the jet streams on our planet by allowing more cosmic radiation in. And if you've been following over the last few videos, I released some information which is big news with regards to our heliosphere now, even during solar maximum 24, allowing cosmic radiation in. That, for the first time, is now taking place. And we know that this cosmic radiation comes through our atmosphere. As a result of that, it increases. As a result of solar minimums, it also increases. And as a result of an Earth going through a magnetic reversal, it also increases, because the magnetosphere, which is our primary defence, weakens and allows this cosmic radiation in. It causes cloud seeding, and therefore making the jet streams a lot more sluggish. So it is more likely to drag this Arctic temperatures, as we've been seeing over in the United States recently, further towards the equatorial subtropic regions, and as a result deposit large amounts of snow and ice. And if it's catching farmers out now, then it's only going to make matters worse further on down the line if these trends continue. Now you would think, wouldn't you, that if a farmer spends £1 million on a combine harvester, probably £150,000 on a tractor, that they would at least be able to afford $400 for a reasonable weather station for that farm. And you'd think that they would be tracking water precipitation, because some of these weather stations now are absolutely fantastic. You'd think they'd track precipitation, barometric pressure, temperature, wind direction, all these things, because you can get it all wirelessly sent to your computer, and you can log all this stuff yourself. You'd think that being in the business of agro, that you would have these things to hand, and that you would collect a record, and then you would know what you're facing. If the trends are continuing in a certain direction, you would know what sort of season you're going to have possibly next year as a result of the data that you collected 4 years on that location, with regards to weather anomalies. But why they don't do that is completely oblivious to me. And of course, if they're not paying attention to these climatic changes, then they're going to be caught out at some point, as we've seen already in the United States, with farmers now struggling to get their crops out the field because they've left it too late, or they wasn't prepared for this Arctic blast that they've got recently. And this is going to keep occurring, guys. If we have a look at the jet streams today, just have a quick look, we will. Here's a quick look at our Luminox atmospheric oxygen sensor. It's used in the aerospace industry, both civilian and military purposes. This particular type of sensor has an inlet and an outlet, and that's so you can pump the air directly over the detector in there. And I've already got the program, or part of the program I need to use with this. There's a little bit of a problem that we've got in that this sensor connects to the Arduino via another board, which increases the voltage, because the Arduinos are 5 volts, but this only emits data to the Arduino in 3 volts. So we need an inverter which steps up the current voltage of the output of the sensor. But it can be done, it's not a problem. But that little thing there was £54 plus VAT plus £20 delivery, £86 I think it came to. But the thing is, with these particular types of sensors, is they're a lot more reliable than the I think it's zirconium oxygen sensors, because eventually the materials wear out in the other type of oxygen sensors, and as a result you're never going to know at what point it's deteriorated, and as a result of that you could get wrong readings. But with this type, it's got a little LED light in there. I think it's a blue LED light, and it shines it on a particular surface like a polished mirror, and that changes the wavelength of the light in a similar manner to our scintillators in the muon detectors. So by doing that, it actually works on the changing of the frequency of the light that emits, and by passing oxygen over that light, it changes the colour of the frequency of that light. And by, I think it's a measurement of the barometric pressure, and the amount of light that's been changed gives a reading of the oxygen levels in the atmosphere. But they're very accurate, and like I say, they're even used in military applications. So with this, we've got a long-lasting sensor that gives us very accurate readings of the content of oxygen in the atmosphere, and it will be obviously wet oxygen, because at 20% measurement of oxygen in the atmosphere is what a lot of people think it should be. That's only measuring oxygen dry content, but this is we're measuring wet content. So it'll be drawing air straight out the atmosphere, which has a little bit of humidity to it, and that's why we call it wet atmospheric air. And it should give us a reading of about 20.9 or thereabouts, depending on how wet the atmosphere is. But it's got, like I say, a barometric pressure sensor in there. It's also got a temperature on board in there. So there's a lot of technology crammed into this little sensor. To show you the bottom there. One of the pins is live, one's negative, and the other two transmit and receive data from the Arduino. And that's how they work. But we used to do it a different way. I don't know if you remember some of the ways we used to measure the oxygen content. One of them was using a tube like that with a little hole in it, and we'd submerge it up to the hole in water, so that we would start at the graduation of 10 mils, and we would put a little bit of wire wool in the end that had been submerged in a vinegar, because it's a weak acid. And then over a period of 24 hours, what would happen is the water, as the oxygen was consumed in the oxidisation of the wire wool, it would draw the oxygen into the wire wool as a chemical reaction, and it would create a vacuum which would lift the water up to around about 20%. But if you remember the last few times we did an oxygen test, we was always getting less than 20%, strangely. I mean, it might be just the crude method of using this sort of technique as opposed to using something more professional like this. But the nice thing about this is we can set it up, and we can set it for whatever resolution we want with regards to how many minutes or hours we want it to take a test, and we can put that onto a data logger and send it straight up to the website after we've processed it, and we can see over the weeks and months whether oxygen levels are changing in our atmosphere. One thing that I was thinking about, during winter times when all the leaves fall off the trees, does that then reduce the amount of oxygen that the trees are putting out? Because I think it does, because I think it's only when they've got leaves that they're able to photosynthesize, because they pretty much go into like a coma over the winter period. So a lot of particular trees won't be producing oxygen at winter times, and I just wonder whether we can detect that with this sensor, whether there's a slight drop during the winter months, that the trees over this northern hemisphere, part of the northern hemisphere where I am, actually don't fill the reservoir of oxygen back up in the atmosphere. The other thing is I think it's interesting because when you just think about it, if you've got a 3-litre engine in your car and you're burning probably 4-to-1 ratio in that engine, then the capacity of those pistons equal 3 litres. And if you're burning every revolution of the engine, a litre or 3 litres, if the car's a 3 litre, if it's 2 litre, it'll be 2 litres. You're burning 3 litres of oxygen or gas, oxygen gas, in that combustion to 1 ratio of fuel, if it's 3-to-1, or it could be 4-to-1, depending on how lean the mix is, or how or how rich you're running your engine. It depends. But when you think about a car, when it's just ticking over and it's not running at any speed, it's just on idle. If you look at the rev counter, most cars tick over around about 900 RPM. So 900 revolutions per minute, and if you times that 900 by 3, you get the amount of oxygen that's been consumed. So 3 times 9 gives you 27, so that's 27 litres of fuel every minute. Or actually, it's actually a lot more than that, isn't it? Is it 270? 270, I think it is, litres per minute that the car's burnt just ticking over and not actually being driven. So that's a lot of oxygen, and that's just one car. And we got millions of cars on the road, so it just makes you wonder, with this deforestation parts of the big forests in the world. We're taking the trees out. They're probably not being replaced at that same rate that we're removing them. So we were actually cutting down our oxygen levels. So it'd just be interesting to see if it does affect the oxygen reservoir in the atmosphere. And it's something I think some of you might find interesting. But we'll be adding that to our observatory as well at some point, and maybe a CO2 one as well, so we can keep tracks on how much CO2 is actually in the atmosphere. I just think it's interesting. So yeah, guys, we'll leave it there. Again, the link's down there if you want to support what we do at the observatory. We do things like this. We don't just talk about things like this. We actually build the equipment and get it out there. And if you've been following over the last couple of days, you know that we're making an effort to get some equipment to monitor the weak regions, the South Atlantic anomaly, which is the weakest intensity of magnetism on our Earth. We're going to get some muon detectors out there. One of these Geiger counters out there, it's got a real good tube in that. It's one of the original tubes that was used, right back in the days of when they first started to build Geiger counters. And of course, we'll put one of our magnetometers out there as well. So, links are down there if you want to help support us, and big thanks to those that have recently, welcome on board, and, more than pleased to have you, with us. So, I'll leave it there, guys. Have a great weekend, and I'll catch up with you at some point. Okay? Bye for now.